I think we'll probably be able to breeze through this one too, because it was super conceptual, too much to actually do. But also, like, I really don't know anything about security, so a lot of this lab is coming out from like no background in it at all.
Yeah.
So I feel like the takeaway for me was just like in the statement, like everybody should be able to do their work, but nobody should be able to work on something they're not supposed to. And it made a lot of sense when Alex, the author, was talking about like this role changing stuff, because like I've only worked in what, like 2 large institutions, and like that idea of like, oh, my role changed today, but like I need to have access to everything in like an hour is really frustrating, because it never happens that quickly.
And yet another story in my workplace is nuts. A lot of our permissions are tied to the computer itself. So then when we got life cycled, when we got life cycled, we lost it. Like,
that is awful. But yeah, that's, yeah, so like that actually ties in with this like least privilege. I had never really thought about this, like least privilege, like having the person, or in your case like the machine, should only have to do the things that you need to do, which I think is a great, like, I think that's actually a pretty good like piece of life advice, life principle to live by. If you don't really need it, then you shouldn't have it. So yeah, Auth is all about balancing these sort of needs. So this distinction between authentication and authorization, the whole chapter uses the analogy of like a building with a bunch of rooms as your organization, and each door for the room has a lock and key, and it might also have like an actual physical person standing in front of it. So authentication is sort of like the process of you going to a door, and the guard has to know who you are before you can do anything. And then authorization is the process of checking that the person who's asking to get in should be doing what they're doing. So for the different ways that it's been doing this, like LDAP, this lightweight directory access protocol, or access directory, this is just the general idea that, like, you know, instead of the guard having to keep like checking every other guard to make sure that everybody else knows who everybody is, it's like giving all of the guards like one sheet of paper that has everyone's name, and when you walk up to a guard, the guard can just check on the sheet. And so in the case of actual IT insecurity, we just know this is like username and password, and like us as like the layman's people of an organization, that's all that we need to do. So we get improved authentication, which is knowing who, but authorization, the what, isn't improved at all. And in the case of like today, when we're working on the internet so much, the communication between like your actual machine and the server where this LDAP isn't always guaranteed to be secure. So that's like one of the drawbacks of this LDAP or AD system. And the other drawback is that every time that you go to a new room, you still have to like, the guard still has to check your name. So this is why like the author Alex says that like this is like the first step, kind of the more simple one.
That's why it's called two-factor authentication, because if you just have a username and password, you know that they have the username and password, so you can allow them, but two-factor codes make it so that presumably you're making sure the right person is using
the
username and password.
Right, exactly. And then so like continuing with the analogy, single sign-on is another way of improving security for authorization and logging. So it's sort of like having your building have a security check-in gate or something. And like when you get to the gate is when you get your like authentication key or like a key card or whatever. And so now that card has already checked that like you are the person who deserves to have that card. And that card as well also has a list of rooms that it's supposed to get into, which means that the card already knows what you're supposed to be doing. So if I get a card and I work in sales, my card doesn't let me get into like IT, for example. So it sort of beefs up that idea of like now you can do authentication and authorization all at once, which I think is really cool. And so this was the first time that I had ever understood what is meant by a browser token. So like in your browser or on your phone, sometimes you get like these messages about like your certificate is out of date or whatever. And then I just like Google it and follow the instructions and I never think about it again. But what it's actually doing is managing like browser tokens. It's these like secure tokens, like just strings that can be in XML or in JSON. And basically like, it's sort of like a handshake where your machine like goes to the server and says, this is who I am. The server says, okay, here you go. Here's a token. Keep this. As long as you keep this on you, I'll let you get to the place that you need to get to. So, you know, another version of just getting the authentication and authorization together in one go. And there are vendors for this. So Okta, OneLogin, Azure Active Directory, all vendors that are pretty common, which is great. Next thing, permissions. So like we talked about permissions in like the Linux sysadmin stuff and as well as when we were setting up the AWS servers. But from a conceptual standpoint, like permissions isn't as like, it's obviously going to get more complicated the larger your building is, the larger your organization is. So like simple permissions, you can just call it ACL, access control list, where it's just like I said, each guard has a copy of the list of your username and password, and then it's like, what can this person do? But obviously that doesn't scale.
Personal experience.
Yeah.
Scale.
It cannot scale. So role-based access control instead defines like groups of permissions by, in this case, like a person. And the immediate like link I made in my head was like the first time you do like Python programming and they teach you how to build a class. And they're like, classes should be able to do one thing and another thing and another thing. And a subclass should be able to do only a few of those things. And a superclass should be able to do those things and more. So it's basically like that. You can think of like the manager can only get into managers' rooms, interns can only get into interns' rooms, executives can only get into executive rooms. And like, instead of saying person A, B, and C has access control to A, B, and C, you say person A, B, and C have managers and person D, E, and F, et cetera, et cetera. So at first it's pretty simple and it's pretty flexible, but there is some complexity creep, especially for like, I want to say people who think they're special, people who think they need more than they do. And we've all been one of those people at some point in our lives. I'm not ragging on anybody here. We've all sent an email to IT and been like, but I need this. And they're like, no, you don't. So attribute-based access control is the next level up from that. It combines that idea of like each person has a set of permissions, but it also thinks about like the task that they want to do and the data as well. But like a basic mathematical problem, once you start making combinations, things get big really, really quickly. And so like, if you've ever seen this this acronym IAM from AWS, the reason that it's so complicated is because of this like combinatorial problem. There are very smart people at Amazon whose whole job is to just make this so complex, but super secure. So if you've ever had a headache, that's why. And then getting to the end, I think like there were a couple things that Alex mentioned that I think like should be good takeaways here. I highlighted tools because like at the end of the day, like being a data scientist is like really about like just moving a bunch of numbers around. But we need tools for doing that, and we shouldn't have to like install our own tools for everything that we need to do. You know, the organization should be able to provide you with that without like jeopardizing their own privacy or security. And so like, I think the better that we can be as data scientists and being able to communicate with them, the more effective that we can be. So like a couple needs are like data access. And there was an interesting point that Alex made here that in moving with the analogy, if you're doing internal data access, then you kind of only need LDAP, which is just the credentials. So you can think of it as just like the same thing as like the key card. Instead of having to access the instead of having to just like do the key card for every single data source you need, you could just like walk to the next room over and be like, hi, I'm Tinashe, I need access to that thing. And then a person goes in the room, fetches it for you. But there are some orgs that do still go the full SSO route for data access. Kerberos is a protocol that people use for that. And then others might use what's called JOT, JSON Web Token. I don't know why it's pronounced JOT, but it is. And Alex mentions that it's rare, but it's still growing. So there's a chance that more people could see it coming up in the future. And then IAM is most often used for cloud to cloud. So like data access from like your EC2 to your S3 bucket, for example, wouldn't need like, wouldn't need something as complicated as like an SSO. And in that vein, there's also service accounts. So the example that Alex gives is you build a Shiny app and you want people to be able to use it, but you don't want to have to sign yourself in as the author of that app to get access to certain data. But the user doesn't have access to that sort of data by default. So instead, you just make an account for your software that gets like limited access to data, for example. And so your users can still access everything that they need in your Shiny app without having full access to data sets. So I think that's super useful and it makes a lot of sense. Okay, so going back to the learning objectives, you re-render this with Utilines. So the difference between authentication and authorization. Authentication is the guard saying who's asking, and authorization saying what do you want to do. Pretty simple. The different ways of managing permissions. I think like when it comes to advantages and drawbacks, I think the big word here is complexity. So I think in order of growing complexity, the access control list, role-based control lists, and the what is it? I forget now. Attribute-based control lists. And I think like, yeah, in order of complexity, I think is the best like way listing like the advantages and drawbacks, because once you get to this end, you're starting to deal with stuff that's just way crazy hard to manage, but super secure. Advantages of token-based authentication and why organizations dropping it. It reduces complexity, in my opinion, by providing that one handshake, but it doesn't solve everything. There are a couple of different situations where like data access wouldn't work for tokens, and also token management. So like your token can, you know, be invalidated on a day where you have something due in 30 minutes. That's happened to me before. It's really annoying. But yeah. So for each of these, he wants us to list if it's a username and password method or a token method. And yeah, PAM, LDAP, username and password, and then Kerberos, SAML, and Auth, all token based. So yeah, that's pretty much it.
Pretty good.
Yeah. Any ideas, thoughts, lingering?
Not really, just that like sometimes you have a mix of different things. So like,
Yeah.
if you, what is it? You can clone an Azure DevOps repository in GitHub Desktop, but you can't sign in through GitHub Desktop. So you clone it and then you use your username and a token as the password. So you create basically the same thing as the GitHub tokens. It's an Azure token. Or same if you're signing in on the command line to GitHub. You don't use your password, you use a token.
Right.
And then some ACLs will also take, they won't necessarily just take users, they'll also take like roles. So you can do like user groups.
Right.
And then I'm assuming same with attribute based, but it's sort of, it's like changing where you're setting the permissions up, whereas ACL is like user side, attribute based is like process side.
Right. Yeah, I think that's a good distinction. Especially like when you're talking about simple things like directory management and stuff. Yeah.
That's
cool. That should be it. And I think Ahmed should be taking chapter 19, but not next week.
Yeah, it's on the 20th. And I won't be here on the 20th.
Right. And then should be the wrap-up meeting.
Yep.
If Alex is able to attend. Should be great.
Yeah, Ahmed said probably 18, but it looks like that didn't materialize. So
I think he signed up in the sheet though.
It will be, oh, okay.
Yeah.
Let's see. Yeah. All right. And then we'll regroup for the review.
Yeah. Awesome.
Cool.
Thanks for coming, Gus.
You got it.
See you later.
Bye.